here and here. Okay. I've been using AI here every day for this Ethernet IP work. I'm kind of finding that for general knowledge, I think ChatGPT is a little better than Claude, but Claude is a good programmer. But the Ethernet IP knowledge is kind of obscure anyway. But I find myself kind of asking both of them questions just to find out, try to home in on the answer.
So ChatGPT is smarter than Claude,
I think for general knowledge, it has more stuff in it.
but for programming,
Well, Claude does a good job programming, but I mean, I've kind of transitioned from having AI write a bunch of code and then, getting very close to the solution, but not exactly there, to realizing, okay, we're right in the vicinity. So I go and I see what it's doing. I clean up the code, fix a little few stray things I notice that aren't right. And then I use it. And then after that, I haven't been having it write code so much as just answer general questions that I need in order to complete the project. So now I've got it talking to the PLC, but I have to maintain a conversation with the PLC for like keep alive purposes, over TCP, where the UDP data is flying back and forth every 10 milliseconds. That's working fine, but you have to respond to these send RR data encapsulated commands that might have multiple requests within each one. So you have to, go through and parse everything. It's kind of you have to get into granny gear and go, okay, well, there's no way around this because a given PLC might give you slightly different requests. So you can't just say, okay, well, if you get this and that, you have to parse. So I'm kind of now just getting into that part. And both
where
AIs,
where the UDP is more like a stream, right?
yeah. Yeah. Once that thing is enabled, it just runs.
Right.
But the PLC still wants to have like little handshakes now and then just to confirm that you're there. And it doesn't seem really necessary to me, but that's what it does. So I have to take in these send RR data packets and parse them and then respond in kind. And sometimes they could even have multiple things in one packet that you need to respond to. So you have to parse it and then build a response packet that contains everything it might need and then send that back over TCP.
Chip, question for you. How much time has Claude saved you in this project compared to what would have been 2 years ago using Google and Forms or whatever?
Well,
Like what percentage of time? You've been working on this for like 2 days a week for 8 weeks.
probably about 6 weeks. Yeah. Well, it caught me in the ballpark. I mean, I went from knowing nothing to being kind of proximate to where I needed to be in, pretty quickly. But then I have to eventually, to finish the job, I have to slow down and learn all the specifics of the Ethernet IP stuff and the common industrial protocol, because that's like its own little language. So there's really no way of getting around that altogether, but at least it, wrote the code pretty decently for the W6100 WISNet chip. And I was able to go in later and it kind of wrote very general code, where it's like checking for every possible error, which isn't really necessary. So I kind of cleaned that up a little bit, pared it way down, got it down to the essentials, and then have been kind of working from there, but more asking AI questions, because what I'm doing is not really programming. I mean, I have to write code for the P2, but I have to know what code to write, and that's so it's not really a implementation problem. It's a what to program problem. The implementation is not that complicated, but what to do is mysterious because it all has to do with this common industrial protocol by this ODVA organization. It's like kind of like USB, but it's it's got some strange limitations. Like there is no query for the PLC to just say, okay, tell me everything you got. It has to know what to ask to get confirmation, which is kind of like backwards to me. It's like, why even? So you have to pre-configure the PLC in order to get it to do anything. It has to either have an EDS file, which is like called an electronic data sheet, or it needs you to go in and manually configure a generic Ethernet device with so many input registers, so many output registers, and then a packet interval. So, and I just kind of finally came to terms with that like a half hour ago, because I was always thinking I could never figure out how this pie is cut up exactly. But now after a while, I'm getting a handle on it. And so I'm kind of reluctantly acknowledging, okay, so I've got to implement this parser that I was hoping to avoid, but there's really no avoiding it because that's just how CIP works. But once I get that done, this thing's going to be totally working. And it'll be then very finite and rational. Right now it's been very open-ended, but that's closing now. I can see the whole thing coming together. We're just a little bit away from having it done. But if I didn't have AI in the beginning and I had to start reading source documents from ODVA and then, the WizNet data sheet, that would have been like a lot of work. So AI kind of got me in the ballpark pretty quick.
Well, I do have a short demo ready.
All right.
Let's see here what I can do. So I have a Claude instance sitting here in a window. There's really nothing going on. Let's see what I can ask. Okay, you have access to the P2 knowledge base. I have 2 quadrature encoders and an e-ink display. I would like you to find.
Wait, I don't see, is it supposed to be
drivers? Yes.
Oh, there it is. Okay.
Still
So
talk?
Steven's talking.
Yes, I was.
And it's translating to text.
Correct. In the P2 OBEX, can you tell me what's available? Oh, yeah. Translation is just fun.
P2O bags.
So one of the things I gave it in the knowledge base is it surveyed the P2 OBEX, and it then can now find things. It keeps a catalog and makes it available. And so it's got a whole tree of knowledge out here for download on demand. And so I asked it a question. It's going to chase till it can find something for me. And I told it 2 kinds of devices that I'm working with. And I want to know what kind of drivers are available for me. And so we used to have to go searching in OBEX and then wander around the search page and do things like this. And we're sitting in our project directory, and all we really want is the driver files to appear in our directory. Whoa. What happened? This just worked.
Was it under some other name?
Yeah.
Or some other description?
Oh, I just got 4 drivers back. When I did this, I demoed it to myself. So what's going on?
double check the prompt that says B2 knowledge as opposed to P2.
Oh, yeah, you're right. But it is using the P2 knowledge base. You can see in the URLs, it's actually using it. It'll do that transform for us pretty easily. Let me see what I can do here. Can you do a wider search for e-ink displays in the OBEX list? I just found them right away last time, so apparently it's occasionally arbitrary. It's like, that's not a good thing. And so it has all of the knowledge we have. It has the full PASM language. It has the full Smart Pens configuration info. It has the full Spin 2 language. It knows about how to create objects. And it has the full P2 OBEX list for P2 categories. And so it really should have found something. And I did this demo before and it just found them right away. So what the heck?
He said, you gotta ask me nicely.
Mm-hmm. Apparently that's true. What drivers do you have that I wrote? Look for Stephen Morocco. It's like, oh, come on. Can you find those? Also, what drivers do you have for John McPhail? Interesting spelling. Let's see if we can see through it. John would be not happy with that. Voice transcription is kind of interesting. I'm using something called Whisper Flow. It's a paid app for Macs. And it's been fairly, it's AI translation in its own right. And so technically, yeah, there we go. Well, what's that? What is that? And John, okay, now come on, John's wrong.
What I notice with all
Ah,
AI, Stephen, is that Claude and Chat GPT does it too, is that if you're dealing with like say a string of bytes that have to do with some packet protocol, it'll
Yeah.
often like misinterpret the fields. And I mean, sometimes it's really obvious, but if you point it out, it can generally correct. But when there's a lot of similar data, it tends to make mistakes.
That's true. Okay, hold on. So I'd like to use the #1 driver you found that I wrote. And then I'd like you to look for more drivers from Johnny Mac, please. He has many more out there. I wasn't in the window. Oh, yeah, pop up the menu on a different window for me. That makes it easy for me to get to. What the heck are you doing? And it times out before I can get to it. Okay, let's do this again. I'd like to use the #1 e-ink driver that you found in your list there. Can you get that for me and put it in? I'm just going to stop there. It knows what to do.
It did find McPhail from the misspelling.
I know. So I just have to make it search deeper now. Please look for more Johnny Mac P2 code examples out there, please. Objects. I asked for drivers, and that may be confusing it. So what it has in the index is links to all of the files. And so it knows how to request them from the OBEX. It'll download them. It will make them available to you. So there we go. Good. And I'll queue up another request. After you're done with getting the list, tell me what I need to do to adjust the driver for my e-ink display. I have this one, which is tricolor. And so that's one I want it to use.
That one's red, black, and white.
Yes. Adafruit now is now selling a 4-color one with yellow in there, or orange, yellowish orange in there as well. I also have a 7-color one. The thing you'll enjoy about 7-color ones, quote unquote, is that it's a minute and a half to paint the device because it's doing the all the layers. And so when you ask it to do something, it's quite impressive. So
Wow, that
go ahead.
so that minute and a half can't be sped up.
No, you have to wait for the device to just finish doing everything it needs to make sure things are showing from all the layers appropriately. So there's not a thing you can do. I write pretty performant drivers, but you have to wait till the device says it's ready. So to adjust the driver for my display, so it looked at the code, figured out what to do. And there are examples in there. And so it's telling you what to do it. Since no P2 drivers exist. Okay. Find all objects from Johnny Mac, please, for the P2. Why is it having such a problem? I've never had it. See, now it, okay, good. It formulated that request very nicely. Sometimes it's,
Well, everyday stuff like this happens.
if you catch
It's
me,
true that if you,
go ahead.
well, if you ever need the computer to work, especially if you're going to show somebody something, then it's not going to work.
It's demos. It's always demos.
Yeah.
So the net result is that you really do have the ability to find the drivers, choose them, it'll download the code and unpack it for you. Now you can ask it to study the drivers, and you can tell it what kind of objects you'd really like in between the driven devices. So if I want to create a backend cog that's watching the device and in queuing changes in the status of the device, I could literally have it create the FIFO for me as a separate object. Well, there you go. That took you long enough. Okay, so it just wasn't happy with me today. Of course, I know it has. It was out there. What I was saying. Oh, so I can write the FIFO object and then queue it off to the display object and have it write the interpreter pieces for what you're getting out of the queue and drive the display. And the way I request these things is to tell it about the architecture and then have it research what drivers are available and then have it download the drivers, study them, tell me what changes I need. It can then make the changes for what pins am I at, what type of device do I have. It'll make the changes to drivers, and then it'll create the interface objects that I need. So something to run the driver in one cog, something to run the pair of quadrature encoders in another cog, watch their changes, and then queue off the changes from the encoders, and then send them to the display feed, and it'll just do whatever I ask and write all the code. I'm enjoying this capability, but if you catch me early in the morning, my voice transcription is much worse than later in the day. And so there are times of days when even though it's slower, I probably would be typing. Get me before coffee. I have those kind of problems too. So it's kind of interesting.
Hey, so you could actually show it now, pulling up like VS Code with your colorizer and actually modifying files.
I might be able to, yes. I never like to do a demo without having done it first, but you're gonna
Well, this is the kind of
challenge-
experience
you're
any
gonna
of us would
challenge
have.
me, aren't you? This is true. This is true. So let me do that. Let me pull up another window. So I have to get something like this, make sure I'm in the right place. Fire up Claud Code right here. It had an old memory of a file I had here at one time. It has left a mess with just putting the stuff right here. But what we found is here's my e-ink driver. And so let's see how far we can get. I don't have it hooked up yet, so I can't tell it to, but I'm just going to pretend. Let's see. First of all, okay, would you bring the object ID 2829 locally, please, so I can use it? So since this is download on demand, it is sucking up conversational context as we're talking. And so it would behoove us to, in general practice, download the pieces, get the pieces organized, move things out of the way that are not going to be in the main project, get it all set to go. And then once that's done, clear the conversation and start over again with what you want to do as an overall practice. And that allows you to clear your previous conversation history and give you a really strong context for doing new development work. So remember that as a practice as we do these things. And I'm just going to walk through it kind of ad hoc. Normally, and what it did, what are you doing? Downloaded the HTML. Thank you. You're not being very smart. Downloaded the HTML page. Seriously? No. In your link for in your information for the driver, you have the URL necessary to download the object. Please use that URL. Of course, I hate that. You're right. It's like, please don't do that. Stop with the you're right. Just do it. So last time I did this, it downloaded both drivers for me. It knew it shouldn't unpack them in the same folder. So it actually made separate folders for them. And this time you might notice that this time around, it's just created a mess. You can see here from the left, all the things are side by side. Normally you wouldn't want to do that. So let's see here. Okay, let's do a bit of cleanup. Move the original objects from each of the two objects, move the original files into their own folder, and put the zip files there as well, please. And so I'm just going to give it pretty general instructions. It generally tries to conform and confirm things with me. And let's see, what can I use here? Well, let's do this so you can see things live in a smaller form factor window. Now you see things being redone here. Maybe. I'm assuming you're seeing both of these windows. I should look at what's shown. Show me. Good. Yeah, okay. Yes. Now, because I run host native, I'm really pretty defensive about letting it do anything at once in the file system. And so it's prompting me whenever I give it something to do. If it hasn't used that command, it's going to prompt me if I haven't approved it for use. Yeah, it's okay. That's better. You can see it cleaning up on the left.
So Stephen, are we seeing the files on your computer, or is this what Claude has in the AI?
Claude is sitting, you see this blue directory right here
Yes.
on the mouse? Claude is sitting in that directory. And so this is the command line, Claude command line tool, CCLI. And it's sitting in this directory. And so this is why, cool, okay. This is why it has access to local files. Okay. Now I'd like you to find the two top level files that represent the drivers or objects and bring those into this folder from their respective project folders and bring any dependencies they need as well. And so it should now copy a couple files out that we need. And so objects will include other objects. And so hopefully it'll study that and bring them out for us. We'll find out.
But the AI is working on the directory structure within your Apple computer, right?
Yes.
Okay.
Yes. The point of using command line tools versus a net-based, web-based, is that I can do that. Right. So here's a case where do I want to do this individual command, or is it appropriate for all of the copy commands in here? It's like, okay, fine, do copy commands in here. And so now it's bringing up the e-ink display. It brought the fonts and it brought the SPI file for the e-ink. That's good. Now let's see what it finds for John's. There's his quadrature coder. Okay. Okay, can you go ahead and test that both of these files compile? That's the quadrature top level and the e-ink top level file, please. And so it knows about Peanut TS in my case, because I'm on Mac. And so I'm just saying, go ahead and test it. And don't ask for those anymore, just do them. And so it generated a binary file for the quadrature. Okay. Unfortunately, it asks about the full form of the commands, so it had to ask about both anyway. And it generated e-ink, so both files compile. Okay. Okay, my e-ink display is based at port 16. Can you change the e-ink driver to use the group at port 16? And what I'm watching for, oh, that's not how we do it, is it? I told it to change this and that's not right. Okay, so let's not do that. It doesn't know how to do that. So no, don't do that. I misspoke. We need a top level object that will include both of these objects. And in the main, we want to set up the e-ink display with the right pins and the right type of display. I need to find out what type of display that is. I don't have that kind of documentation in the source code itself. So I have to go out to the repo for the e-ink. It's like, which one is it? Oh, I wonder if the OBEX is old too, if I updated my latest. So I added a couple more displays to it. And shame on me if I didn't. What do I want? On my EE repo. So I'm out here looking at this, wandering through code. And this one has touch, wave share. Oh, red, black, and white. Okay. That's probably the one I want, but that means the driver we have here doesn't work. I got to push my new one to there. So I'm just going to pick one. Wave share, WS. Nope. WS is not in the list of drivers. So, okay. We need a top level, set up the ink display with right pins and right type of display. My e-ink display is on the pin group that starts with P16. And let's set up for the DS e-ink 200 display. So these should be in the start command within main. I wonder if it'll actually do this. This is one of my first times trying this. And so now I'm going to bring this while it's doing this. Let's make this smaller so we can see it and the code. And we'll make this, what's it doing for a top level? You don't see it yet. So I can't show you the code yet. Move this over. Hey. Cease and desist. Just randomly click on things, Steve. Main e-ink encoder. Okay. Sure. Oh, I should have said allow edits. Okay, so here's what it's producing so far. And interesting. It knows I have two encoders. It's putting them out as 1 and 2. It did my 16 pins, checks for invalid pin base. And it did all that code correctly. Not terrible. This is probably a highlighter issue in my code. Let's go find out. It may not be. Can I say my words? It may be that it hasn't looked at the interface yet. So we'll find out. It's not going to compile if they're wrong. So let's see what it does. It's interesting that it just went straight into the compiling. It's like, oh, yeah, okay. Yep, it found some errors. I need to check what methods are actually available. That sounds useful. And so having looked at the methods, it's now correcting the code it thought it should generate. So this is the diff, right? So there's the, and I said, go ahead and write it. I should have proved all the edits. And so you can see what's happening with the highlighting now. It still doesn't like the number to decimal stuff. Wants to allow all edits, please. Stop prompting me. Thank you. Decided it needed a buffer. So I just turned it loose on what I want. And I'm letting it do all these changes. I've worked on very large code bases. And when you do that with very large code bases, this stuff scrolls by at a screen, making changes constantly. Again, for similar commands, what did I just ask you to do? You're just combining. Yeah. So it's using the compiler to tell if the code's correct, and then it's going ahead and fixing. And you can see it's actually doing quite a credible job in the code it's producing. This is our this is Claud Code, who's never really been trained on P2, but has access to the full language now that it can study. And so it's getting there. And it says, well, that's probably not the right way to do that. It's fixing this. It makes some really strange guesses for how to write code. But it works its way through and it gets better over time, which is just fascinating. Got the operators wrong. Oh, we got to object this time. That's a change. All right. So I just told it how to start it up. It worked through all the issues and generated the code and now has the information there. And so theoretically, now I haven't told it where the encoders are, which is interesting. It has created constants for the encoders. It assumes we need them, and it is correct. And so one of the first things I'd be doing here is telling it what pins am I actually mapped to. Since the encoders require a 5 volt and ground and 3, I'll probably put a single encoder on each header, and just because it's easier to get all the wires near each other because I'm using the standard plug wires. So my encoders, okay, so I'll probably just wire it up that way. One to each header on the board and tell it which pins I want. And from the moment I tell it the pins, we should have that. Now let's see if I can challenge it. What do I really want to do, Art? I don't know enough about the encoders and how they work right now in the object. Okay. Tell me about the encoder object. How is it shaped? How does it run? Does it have its own cog? What kind of values do I get back from the encoders? And so I'm asking it to go out and tell me about the code because I don't know anything about it. I could look at the code and read it, but it's pretty good at this. And so I'm just going to let it be as good as it is and tell me. If you have a source code and you want it documented, you describe your documentation style to it, and it will do that, which is kind of fascinating. So here's what we learned about this. Object analysis. It does not run in a separate cog. It uses smart pins. A and B must be within 3 of each other. We have the phase pins, we have the button, and then we have true if we have detented encoders, and mine are detented. Okay. Preset low and high min. Okay. Values for clamping, so we can set the range. And it will return the assigned integer position code and clamp between low and high. Relative preset. Okay. So I can see right away that I kind of want to let this freewheel, but I kind of want to limit it since I'm going to be, if I'm thinking in terms of a silly etch a sketch, one of them might be vertical, one of them might be horizontal, and I'd want to clamp the limits to 0 through n of the display size for horizontal vertical. Since the display is not that big, a single word could contain both X and Y values. So I probably want a cog that would look for X or Y to change and then queue off the pair every time one of them changes. And so that's the way I'd think about the problem. And so if I want this to be, let's see if I can make this do this. Can you create another object that is going to actually have these quadrature encoders? It's going to drive the quadrature encoders and read the encoders. And so we won't need them in the top file. I want it to run, I want a task to run a separate cog that's going to pull the encoders, and when it sees a value change, queue off the pair of values, the current value for each encoder, along with the button press information to a separate object. And I'll give you that separate object shortly. Let's see how far we can go with this. Do people want me to continue? I'm just going.
Yeah, I'm fine. I'm getting together some stuff to show here on my end too, but I'm
Okay.
not using, this is just Claude. I'm not using your setup yet.
Okay. So now it's going to go off on this tirade here of trying to create another manager. Let's see. So we decided that we have a word to carry the two values, but we're also going to need another word. So we'll just go with the long to carry the button values for the two encoders. Because we don't know when we're going to care. So I'm just going to queue all the traffic off at this point. Actually, what I'll probably do is keep a separate queue for button changes so I can put up a display where I can switch colors when I press button or clear the display or things like this. And so I'll probably think about that. So it's off going writing files. And what did it decide to create? Encoder Manager. That's not a terrible name. Here's the new code it's coming up with. It did pick up the two encoders. It's got variables we want. It's got the null standard object shape because I taught it about the patterns for how to create objects. There's our start and our poll time. And there's our stop. Then it sets up the pins. Does a start for the two encoders. Stop. Running. Cog stop. Tell me about the start. That must just initialize the pins. Get current values, queue count. Where's the task? Do we actually do a cog spin somewhere? It's pretty quick at writing this stuff, wouldn't you say? Gee.
Oh yeah.
Okay.
Amazing.
Yeah, let's see. Okay, just keep doing what you're doing, please. What are we doing now? Oh, it just compiled it. So that compiled. Okay, fine. Right, that runs in its own cog and monitors both encoders for changes. How did it get to its own cog? Monitor task. Right there. That was pretty expected. What did we do? Cog start, cog spin. There we go. Not a bad start. All right. So it looks like I got a twin encoders running in there. Okay, so now poll, poll. We have to encode. We got the two values, check for change. If they change, we have a change. If they change, we're okay, it's doing its own queuing. Okay, good. So now, let's see. I would like a separate object that is nothing more than a FIFO. I'd like you to take 4 values and code the values into a long for each element in the FIFO. And the 4 values would be encoder X, encoder Y, and button X and button Y. Let's make the FIFO say 64 longs deep. I want you to use a push method for putting it on the FIFO and a pop method for getting it off. I'd like you to also have an observe method that'll return the total size of the object and the current occupation of the FIFO. We'll use that later. And so I described the interface to it, thinking through the problem. I want it to see what it can do now. I would expect to see an object with its own data structure. Since it's a singleton, I didn't say that it should be a singleton, but it should have, we need to make sure the storage is in dat. So let's see here. I also need this to be in singleton form. Tell me if you know what that is. What I mean is that all objects that refer to this object get the same storage. Hello? There we go. Okay. So, it gets frustrated with me, I have to tell you, because it's built normally. I'm using Opus right now, and I've used it today, so it's going to fuss at me about Opus limits. You get 50% of your time for the 5-hour block or whatever to Opus, and then it's going to transition. Anyway, it gets frustrated with me because until I told it that I'm me and this is the way I think, every time I interrupted it, it would stop what it's doing and take on the new task. And finally, I said, listen, the way I work is I'm multi-threaded. I think a lot about different aspects of the project. When I give you something to do it to completion, acknowledge to me that I told you something, but continue that you're working on. Then come back and work on the new things. And as soon as I did that, life got much better between us. So that's important to know because it would never finish work. And I'd think the work was finished and I'd have pieces of things laying around. And that's just too much of a mess. And so I finally got that in control. Also, if I were doing a project like this for real, I would be doing a planning stage, which would describe all the different objects, which would describe what devices are that I have, where their pinouts are, how I want interaction to be between the objects, and I would iterate with it on the plan until it said it doesn't have any questions about my plan, and I liked everything it told me. We would sit there and iterate forever in planning mode. As soon as we hit that point, I would say then to generate a whole bunch of tasks that are paragraph in length, that are rich in content, that leave no questions unanswered, that talk about edge cases. And so each task is self-contained. It then creates the list of tasks and it operates them on them one by one. And so then it's outgoing, creating this file, creating the unit tests, creating the documentation, and it'll do all this at an amazing speed. So having this whole project running, if I had my hardware hooked up, would actually be something quite feasible to accomplish here. Let's go see what it did with our FIFO. We have an encoder FIFO object. And we said, and it's really? It went more efficient. It's using longs. It decided not to use byte boundaries. Oh, 12, 12, 4, and 4. Okay, sure, why not? I didn't say sizes. That's a reasonable approximation for what it's doing. So here's our long. That looks to be specified correctly. There's our init for the FIFO. The data is all in DAT, so it is a singleton form. Good job. We preload the FIFO with zeros. We have a push event. And if the item kite, it'll count overflows, is what it tells us. Okay, fine. If it's counting overflows, then I also want to return that in the monitor thing too. Oh, what happened with FIFO size? FIFO size is what? Should be a return value. Why is it giving me grief? We used it in multiple places. It's a constant as well. Okay, we have some information to learn. That's something I should talk about the language. I need to teach it a little bit more. Okay, spin 2 is case insensitive, and you cannot have return values or local variables or parameter variables that eclipse constants or global or vars. Can you make a change to fix that, please? And of course,
You too. See ya. I'm
okay,
sorry.
Okay, bye.
Should have muted.
Okay, I have to get my transcription history and now paste it because it wasn't in the right place. All right. Okay, so here's it described the FIFO object you created. Okay, so now what we should see is this red should go away. It's already gone. Damn, it's quick. So I had an error in the file and I told it how to resolve it. And I could have let it find it at compiling, I guess. Or maybe it already found it and I didn't catch it. Count available FIFO size, FIFO size.
Steven, this is freaking amazing.
Isn't it fun? And so you can imagine, John, for your work, what you get done. All right. Okay, where are we? Sure, keep working on it. What are you doing now? You're compiling again. Okay, fine. The other thing I'm not showing yet, John, is I have a new downloader and terminal window display mechanism that is coming to release in the next week or two. I'll probably pull out the first release next week, and it'll have some of the windows, but not all of them. It's a parallax serial terminal replacement. It works on all the operating systems. It is high performance, so you can log at 2 megabit, and it'll capture all the traffic with no loss. It will log all the traffic in case you're doing regression testing. It will split apart the windows like Johnny Mac was asking for. If you have lots of logging coming in from different cogs, it'll have 8 different cog windows, each doing their own logging. It has different fonts. So yes, John's 3270 font is in there. Let's see, what do I want to say? And all the debug windows are going to be in there over time. I have 5 windows in there so far. And so imagine then with John's overlay technique that he asked us to put in, then I can ask Claude to create, I want a equalizer, single bar equalizer kind of display, an LED that lights up vertically. I can ask it to generate the bitmaps of, I want the LEDs to be, let's say 10 pixels high by 30 pixels across. I want maybe 12 LEDs stacked. I want maybe 1 pixel margin between the LEDs. I want them to be off and gray, and then on, I want them to be blue. And then I want maybe the top 30% to be, top 20% to be red, and the top, another 20% below that to be orange. And then I can use the have it generate display and show me the Q FIFO status with this monitor method that I showed. And so I can have a term window that actually displays the FIFO occupancy. And so for my unit test, I can have another cog just keeping that term window up to date, or my functional test, and just be asking for these things all by hand, all by voice, I should say, by hand. I'm not typing if I can avoid it. So there we are. Okay, renamed all the parameters so we had different things. Portion pop, thank you. No naming conflicts, stat variables and method. Good. Okay, so we have that up. Let's see. Okay, now.
Now, will he remember that for future, since you clarify that those can't be conflicting, and you won't have to say that again?
In your environment, maybe, but likely not.
Okay.
And so what I have to do is I have to expose that and remember to myself that I have to go back over to the knowledge base and add specific details about the language that apparently I neglected to add, because it should have found that out when I was writing Spin. And so I have to go back and add that. This is a download on demand system with something well over 1,000 files. And so whenever it needs something, it goes and looks it up. So you can ask it to describe how to do ADC smart pin use, or how to do DAC smart pin use, and it should be able to describe things to you pretty well. I have this little Charlie Plex LED board, add-on board, and it has the data sheets for that. And so you can ask it, well, how do I write code for the Charlie Plex LED board? And it can actually help you generate the code for it, for all the add-on boards in the eval hierarchy.
But he says the FIFO's ready with no naming conflicts between constant, DATs, and method parameters.
Right.
So
he fixed that code.
He won't remember that.
Correct. He won't remember that now. He will once I add that knowledge to the knowledge base, it shouldn't come up anymore. Is my point. If he refreshes himself on how to write Spin, he'll get that knowledge that those can't conflict in Spin. And then from then on, he'll just create things more correctly. So what I'm suggesting is that I lost some of that. I didn't have some of that information encoded in the knowledge base. And that's why he made that assumption.
Now, will he remember that for me since you told him?
No.
Like,
No, there's no memory for across instances at all.
Okay.
So that's why this knowledge base is so important. All the PASM instructions, all the spin methods, all the constants, all the smart pin constants, everything all had to be learned in this and encoded in this knowledge base. And so I've been doing weeks of training, weeks of studying and encoding, and teaching it how to build data for another instance of itself to use. Right. And so
but I'm still confused that the knowledge base means it helps others too, or just you?
No, helps others. Let me show you what I mean. I assumed you knew what I was talking about, and that was a bad assumption. What you're looking at is this. I'm going to throw a window on screen. P2 knowledge base is a repo, okay, of mine. And what I told Claude, I'm going to take that away for a minute because I have this. What I told Claude to do, and I want you to show me this in preview, please. Thank you. It's just easier to read. This is what Claude has built for himself as a memory. And compiling, uploading, it's already found load P2. It hasn't found my term yet. It'll have that in mind when I get my term released. Here are the development tools. All right. Then terminal mode for loader, file extensions. And then here's what I told it. I said, here's how you get to the knowledge base. And then here's what you do with it once you get there. And that's all we told it. This is the entire hookup to the knowledge base. And so that's actually in a cut and paste at my website. So you go to my website, the knowledge base URL, and I'll just put it in chat here so everybody has it. If I can find chat. Show me, thank you. So I pasted the URL for you. So you go to that URL, you'll get to using with AI guide. And it says start here if you're using Claud Code, GitHub Copilot, or other AI assistants. And you go to that, and it's going to give you a thing to copy and paste into Claude when you first start. And it's going to tell you to do an init because the init creates this Claude MD in a new folder. And then once you have this Claude MD, then you can tell it, copy and paste, put this in your Claude MD. And from then on, every time you fire up in this folder, it's going to know where the P2 knowledge base is. And that's all of PASM, all of Spin, all of SmartPens. That's all of idioms that we've exhibited in all the objects in the OBEX. It's all of code patterns that it found, anything that was repeated code patterns or repeated use, which were idioms. And as authors of our OBEX, we don't use very many things. I was surprised at how few idioms we have in there. But anyway, it found all of those. Okay, let's make another adjustment here while I'm thinking. Okay, you have the encoder manager, and you now have the encoder FIFO. What I'd like you to do is adjust the encoder manager to use the encoder FIFO when it has changes, to post those changes to the FIFO, please. And so now what we should see is I should see manager here being rewritten to use our new FIFO object. And so again, if I were working in hundreds of files, I would have had Claude study the task list, order the tasks first, so the FIFO was created first. Then when it created the manager, it would know to use the FIFO, and I wouldn't have to go back and rework things, right? So sorting the tasks that you're doing by doing foundational work first and then doing real work later will reduce how many code changes you have. You can see, though, how quick it is at making these code changes and how comprehensive it is. I mean, look at these. It says all of this becomes a push event, and there's the comment for it. So it's amazingly fast. And it knows to just keep compiling it. It says, okay, now it's using it, and the code still compiles. Okay. Okay. Now, imagine that it's a little bit faster than I could be, I think. The tongue-in-cheek. Imagine that it has the ability to download with Peanut Term TS, the new piece that I'm making. Peanut Term TS automatically logs. So we teach it to use debug logging, which gets written to the logs in all the code it writes. Then I ask it, you created a FIFO. I want you to create a unit test for this FIFO. And I want you to, for checking the behavior, I want you to use debug statements. And then I want you to download it, run it, check the debug, and correct it until the test says the queue is running and the test is correct. And it'll sit there and loop and just do it until it's done. So now where you haven't done unit tests before, you can literally, for every object that you have that is a data service, non-hardware related, you can fully wrap that thing in a unit test and have it certified before you call it ready to commit in version. This is stunning with the amount of work that we can do. And so I really needed what happened when I saw Claude, and it was pretty good at understanding P1 and P2 initially without knowing the details of the language. But when I told it, I said, you know, I have to see if I can make this really understand the language. And that's what I've been doing for the past couple of weeks, trying to make this happen. And when I first met Claude, Chip can tell you, I told him, this stuff can't be done. I don't know any way to make this stuff happen. And Chip says, but we need this. I said, okay, fine. 3 days later, I came to him and I saw how to do it, but it's going to require a bit of work. And here we are today doing it. So pretty cool. Thank you, Chip, for the inspiration.
Amazing.
Well, Steve has good management skills, so he kind of applied that to this, and that's what made this work.
So it's an effort trying to figure out. If you think about it, the information, the thing that made P2 knowledge base, I chose this name for a reason, P2 knowledge base, is that the issue we've been solving or facing as developers is, since the P2 was released, we've had to wait for documentation to arrive. Manuals would arrive as things were written. They get improved as things were written. And to this day, we're still waiting for a couple of things. And so I figured, okay, we've got to understand the P2. And so what I built was a system that studied all the documentation in detail. It would read all the documents, ingest the documents, ingest all the code snippets, all of the images, pull them out. It would compile all the code snippets, make sure they work. And then it would look for conflicts between all the documentation sources and where we have questions that we haven't answered. We even gave it the chance to study the compiler and learn about all the PASM from the compiler and learn about all the spin from the compiler itself, PNet TS source. So first principles, right? Everything, solid truth from the ground up about everything we know about the languages. So that's why I call that knowledge base, because it is going to be the strongest set of information we have. What this is allowing us to do is audit how much we know about which regions of the P2. So now Chip is working with me to fill in some of the areas that are a little bit weaker. What that means is that we can generate the full PASM manual with the full richness of description for all the instructions that are currently missing. We could go back, if we wanted to, augment that manual or make a companion manual that has examples for all the different assembly language instructions in their use in context. We already have, I don't know if you remember the P1 De Silva manual for learning assembly language for the P1. It was written by a university professor in Germany. I forgot his first name, but his last name is De Silva. And he used a very intentionally learning or training manual concept for his students in college. So I took that manual, studied it, and asked Claud Code, Opus, the expensive model, right? Opus, to use the same voice, improved pedagogical techniques, and generate a full P2 De Silva manual, full explanations of all the areas of the code. So you get a full chapter on using Cordic. You get, all these different features are described in the manual from an assembly language perspective. So if you're a university student wanting to learn something about this, we'll have that available. And so I'm using this full trusted source of knowledge to help improve our documentation state as well. So that's coming. Takes a little bit of time, but it's coming. To augment what we're learning here. Okay, where did we leave off on this thing? Do I know? We have FIFOs. We don't have anything sucking the FIFO and driving the display. Okay, here's the next piece we need. We need something that's going to listen to changes in the FIFO, receive traffic coming in the FIFO, And for the X and Y values, plot pixels or draw lines to from previous location to the current location on the e-ink display. So we need a cog that should run and manage the e-ink display and be watching for FIFO changes and just updating the display. Let's build this. And so let's see if we can get this piece in the mix. So now you notice I'm not specifying names for things. I could if I wanted to, but it is way too creative on generating names for things, and it's not bad at it. The unfortunate part is if you ask it to change files and it sees a repair, if you're not careful, it will say, this is the improved one, or this is the underscore simple version, or this is the final version. And I've had it give me 6 different final versions over time. And so you have to be a little bit careful about its file naming creativity. And so when we're working in code, I'm going to be careful, especially with scripts, it keeps renaming them. But with source code, it's not going to do that too much. So you're not going to have to worry about it too much, but pay attention to it. If you lose a file, it's probably because it wrote a different named file out there. It's like, what do you mean my change is up there? Oh, it's over here in this file. So that can happen. You have to pay attention. This can behave anywhere from your coder who's just learned to code in high school to just graduated from college, has no experience, to is a really senior encoder, is a really senior coder. But that's all based on the amount of guidance you give it in how you ask for the work to be done. You can see it's not doing a bad job right now, and I'm not being too careful about it. But the point is to demonstrate how we think about it, how we ask it to do things, and see what it'll do. And we learn to make changes based on the reactions. So here we are now. What do I have? I have a new e-ink manager. Yeah, display manager. Here we go. So now we're working on this one. Because I told it the display, it knows the width and the height. Okay. So let's see. We can see already, there's our FIFO, there's the e-ink driver. There's the cog for it. We're starting here. That means this has to be, okay, good. That means we have to update our top level for these new manager objects. We haven't done that yet. Requires a little bit of project management. It's like you had this engineer off doing the side, you're asking him to do piecemeal work. Don't forget what you're asking him to do, because it'll just leave things unconnected. So you kind of have to remember what your last has and what hasn't been done, what has been done. That's why you do the planning up front. So if you do the planning, you don't leave holes. When you're working interactively, it's real easy to try and test and realize that you forgot to hook up 2 of the objects. So planning is your friend here. Generating detailed tasks is your friend. I'll have a video with me going through and doing this for real. And that way we can refer to a video where I've done things in a way that I want people to practice versus ad hoc like we're doing it here. Once again, we're getting reliable code, well-shaped code, no surprises. Now.
But you said you don't have the hardware set up where you can run it, right?
And I have an Edge module right here with a P2 powered up with a logic analyzer hooked up to it. So I'm minutes away from it, but I don't dare. Because inevitably something will happen with the hardware and we'll go down a 45-minute rabbit hole trying to make it work, and not for presentation. I will take it through to fruition and do this whole thing under video though, and we'll make it happen. Okay, system is now complete. We have encoders to FIFO to display. Okay, cool. You have a top level file that runs our whole system. Let's update the top level file now to be correct with our new managers. It's an ugly way to say it, but I think it'll get the point. So let's see what it does. What is our top main e-ink encoder? Is that this guy? I think it is. So we should see these guys go away and our new managers show up now. Yep. See, it already recognized that it needs to. And so let's see what it thinks. So it's not uncommon for us to have this reasoning path anyway as we're thinking through projects. Look at this. I mean, this is just stunning. Bam, it's done. It's like, ah! This is this strong, and it's got the compiler to iterate with. There's absolutely nothing to the fact we cannot trust this. We have to verify. It will not generate 100% correct code. It just can't do that. So letting it iterate and test by reading logs is huge. You can see that it compiles it and realize it got it wrong, so it recompiles it again. So it does like to iterate. It will fix things that it needs to. That's perfect. That's also excellent when we actually have hardware and get the hardware wired up. The one thing I'm missing in my tool bench is having a logic analyzer that Claude can see. So maybe we do a logic analyzer cog implementation that monitors pins, and then we can use a P2-based logic analyzer in one of the cogs to feed us test data. And we can actually review the signals and figure out what's happening and see if we're driving the signals correctly. So that could be coming. We might have to think about these type of techniques to make it. There's nothing wrong with, even if we're doing a high density, high number of cogs application, that says that we couldn't have a second edge module sitting right next door being our logic analyzer and scope. So if it's going to facilitate our being able to develop projects like this, it seems to me that that would be a smart thing to do. So there we are. I think we've got ourselves to, Chip, how are you doing for being ready for a demo? I think we've...
Oh, it's just kind of general Claude's demo. It's nothing as it's more forensic than creative.
That's kind of perfect, though. We need that too. Okay, so are we happy with this presentation so far? This has been pretty stunning. This would be great, a great study in how we've done something. We've gone from having a hard time finding the drivers, I don't know why that happened, to downloading the code, to putting the code in project shape, asking Claude to generate all the supporting files for how we want to run things. And without hardware, we almost have a running Etch-a-Sketch here. So this is probably going to be hook up the hardware, prove that it's all working with existing objects, like running John's demo to prove the hardware, the quad encoders are wired up correctly. And then tell Claude to modify this one to use the new signals. And now that'll be working. And then we can hook up the e-ink display. We can run the demo that I provided, make sure the hardware is working. Come back here, modify the pinup, and then this thing should fire right up. And so that'll be my approach to going live with this. And then we'll dial it in. There's no reason that the quad encoders shouldn't be pre-scaling to the device. I could do that in the cogs and pre-scale there, so the values I'm getting are legit for the e-ink display. Or I can choose to pre-scale on the e-ink side of things. So you have a lot of freedom in implementation. Any other questions about this before we end this particular demo?
Yeah, good job. It would be really cool if we could come up with some kind of demonstration where at a very high level, you give it a task and it writes the code and we can see it run. And it would be neat if it could even, and also another thing where maybe it could iterate on some code and we could watch it modify, look at the debug output, change the code, run it again, and home in on our result.
We are almost there. I'm working on the final packaging for Peanut Term now for all platforms. Once I have the final packaging, we have, if you don't pay attention to the debug windows, we have a full round trip downloader, flasher, and logging system. So the first release will support that. At that point, we can do a full demo, full round trip from concept to implementation functioning. If I throw up an external camera to watch the hardware, we can actually then see external devices behaving correctly over time as it dials in the code. We can get there too. So that's all going to be feasible. With the system we have today, you can get to, you're ready to download code and run, but you have to do the final testing. In another week or so, I'll have the mechanism so we can have Claude do full round trip. I'm anxious for that, Chip. I want to see that happen.
Yeah, because that's where it'll tie together, and it'll happen in a short enough time that it'll capture people's attention spans
Exactly.
without needing to be, have any esoteric knowledge.
Exactly. So what I'll try and do is have a fully flushed demo. By the next time we do this, I'll have a full round trip demo of something small so we can have it do that. And I'll probably focus on less hardware, but debug windows. Point being is that debug windows are any hardware we want. And counters and timers and waveform generators can be done in the P2 without needing external hardware. And so we can feed whatever displays we want.
Yeah,
so
that's a good plan, Stephen.
I'll probably do that for the next demo, and we'll go ground up on a concept. And it can do everything for us. That could be fun. So also expect on my channel, I have an Iron Sheep YouTube channel where I put occasional things that I like to do. And I'll be, as I do a project, as I bring this one to finish, for instance, I'll have a full ground up creation. I'll be going through this all again. It'll probably generate slightly different code. And I'll probably do it with best practices in mind so that I can generate a full video on this and how I do it. And so that's coming. A number of these small videos will be there. Okay, any other questions?
Thanks, Stephen.
All right.
Yeah, thanks.
Welcome. You're very welcome. I'll stop my share, Chip, and let you go from here then.
Okay. I will share my screen. Let's see if I can make my screen a little smaller so it's practical for you guys to see. I have a TV. Oh, did I just? Oh no, here we go. Hold on. Okay, now I'll try to share. All right. Here we go. Okay, let me get down here carefully. All right, is that visible to you guys?
Yes.
Okay, so you can see on top here, we have VS Code.
Mm-hmm.
And we have down here, we have a Claude window. Right, so what I did is I opened up a Claude session and I asked it, could you open the Spin2 interpreter in VS Code, which it did. That's right up here.
Mm-hmm.
Then I just thought I'd ask it some questions. So I asked it what it was, and it says, oh, this is a Spin2 interpreter for the P2. It executes Spin2 language on the P2 chip. The code contains a runtime system that interprets Spin2 bytecodes and blah, blah, blah. So it got that right. So I asked it, okay, well, what does the task next do? And it located it. Let's see here. Let me find it up here. Here we go. So this is part of the task switching system. And it says, oh, it saves the current task execution state, 8 longs, and it sees the variables down here that it needs to save. It says it stores the stack pointer into a task pointer list. It finds the next unhalted task. You could get some of this from the comments. But anyway, It's pretty interesting. It can just, what if you or I had to open something from some other chip that we knew nothing about? How well could we interpret what it was about? And it says it's the cooperative multitasking scheduler. It's not exactly a scheduler, but it's a switcher. So then I asked it, okay, how about how many clocks would byte swap take to swap 1K bytes? So let me look up byte swap here.
Sweet.
And we could try yours, Steve, because I had to do something. You'll see here in a second. Byte swap. Okay, so it actually found the code right down here. It dug up this code here. And it said, okay, let's see, where did it do this? It started looking at a lot of code, and it says, okay, based on the code at lines 2196 to 2208, that's down here a little ways. It's from here to here, swap buff. In here, it says, okay, so since it's swapping longs, not bytes, it does whole longs and it handles any trailing bytes. So it says it recognizes it's going to have to do 256 swaps. Then it looks at the code on 2196 to 2201. It knows that this is the initial loop in which it swaps whole longs. It says it made a mistake. It thought everything was 2 clocks. So it figured there were 6 instructions there, being these, and then it multiplied that by 256 and it said, 3072 clocks. And I said approximately 3100 clocks to swap 1K byte. And I asked it how long that would take at 320 megahertz. And I hadn't really scrutinized yet, what its computation was. And it said it would take 9.7 microseconds. So I made a little program to actually do that, which was right here, right?
I don't see it yet. There you go. Okay.
And so I'm just gonna because this is a tiny program, this 8,000 and 9,000, those are open. There's 1,024 bytes. So I looked and it was taken about, looks like on the scope, about 40 microseconds.
Yeah, so you did 10 high, 10 low, and measured on the scope.
Yes. Yeah, and I can't move the camera on the monitor over there because it's stuck on top of the monitor. But anyway, I asked, can you rethink that after looking at the instruction set? So I gave it the URL to that Google sheet where we have all this instructions listed. And it looked at it. Okay, it homed in on read long and write long. And then it said, well, let's see, they take variable time depending on the hub slot alignment, typically 7 to 16 clocks per access, not the 2 clocks for register operations. So then it started looking at this and reevaluating it. And then it came out and it says, okay, 30 to 66 clocks per, and that would recalculate everything and said, 38 microseconds.
That shouldn't be correct though, should it?
Yeah, that's what it is on a scope. It's like, I saw 40, but it's probably more like 38.
Once you get aligned, don't you stay aligned?
That, I don't know. Well, because the addresses are changing, we're not really staying aligned. Well, wait a minute. Let me think about that. Yeah, because we have to wait for different offsets.
Oh, because you're doing a source
and increment.
You're flipping between 2 locations so you don't stay aligned.
Right, but that's right. Yeah, that's an issue. Plus, as we increment, we're changing the hub slot that we need to wait for.
Yes, okay.
So I mean, here I saw in the scope, it was 40. It looked like 40, but it's probably more like 38. And it recalculated and said it would be 38, which was right.
Beautiful.
So now your setup might come to the proper conclusion immediately, right? Because you have this knowledge trained into the context, so it can probably compute it right off the bat.
I would hope so, but you never know.
Especially if we're trying to show somebody.
Yeah, exactly.
Yeah.
As we just saw, it forgot how to even find things it knew how to find an hour ago.
Yeah, yeah. Oh, could your context be getting stale?
No, that was a new conversation. So it
Okay.
shouldn't even have any effect from an hour ago even. So yeah, I'm confused.
You see this code here?
Yeah, the translate table.
Yeah, this is out of the interpreter, right? So I have these different bytecode patterns, and it can compute. A and B are falling down. They're pull count and lookup over here. But from C through M, these are the actual equality checks.
Mhm.
So I asked it, okay, let's see, where did I ask it this? I asked, can you explain how opera works in the interpreter? And so it looks around, pokes through there, and it finds 30 lines, and it says, okay, opera implements all the relational comparison operators, being these,
Mhm.
using a code sharing technique. And then it says,
Well,
okay, it pops two operands. Oh no, well, X is already on stack top. It knows that. It had to pop W, which it does right up here, right? And then it has basically 4 different compares that might happen. And so it says it uses bytecode bits to select the right exit path. So each relational operator bytecode has different bits set on lines 983 to 993. If we go there, let's see, 983. Yeah, here they are where it's highlighted. See, it's talking about these bit patterns. So it understands, it was able to figure out what's going on there. Oh, and then I asked it how get MS works, get milliseconds. Let's see, let me go there.
it's pretty fascinating what it can learn, isn't it?
Yeah, and it's just doing this just from inferring and with what little knowledge it knows. It has a little more knowledge because I pointed it to the data sheet.
Sure. But
Okay,
this
so
is,
here's, oh, sorry, Stephen.
no, this is how I told it to dump the byte, give me a bytecode table for the bytecode interpreter. So tell me what the bytecodes mean, right? And then
Oh,
basically asked it to study this file and said, tell me what they mean. And it's pretty amazing. It gives you a full description.
yeah.
Yeah.
It did. The other day I had to look at get MS because I was worried it might have a wrapping problem, which it doesn't. But anyway, actually it does have an eventual wrapping problem, but I think it occurs after a couple years at 300 megahertz, which is probably never going to happen.
Do not care. Yeah.
Yeah. But I kind of had to refresh myself. So I thought, I'll ask it, how does get milliseconds work? And it looks at it and it goes, oh, it gets the 64 byte clock, divides it by clock freak, and then it gets a whole second. So in the case it gets seconds, it just returns the number of seconds. And so for get milliseconds, it multiplies the whole seconds by 1,000. Then it takes the remainder and multiplies it by a scaling factor to get milliseconds, and then it just adds them together. And so it was able to kind of figure out, I mean, it took me much longer to look at my own code the other day and recall why it was working than it took this thing to just explain it. Anyway, that's just raw Claude without, any special knowledge.
That's
Too cool.
Let's see, I'll stop the share here. So I don't know what else to say about this, but it's been useful for me working on this project for Doug, and it's saved a lot of time, and it's kind of interesting, this whole advent of this ability for computers to actually do this kind of work is like the first in history, and we're living through it. But it really is, it's a big development. I mean, I remember when I saw that Star Trek movie where Scotty talks to the Mac and the Mac doesn't respond, and I was thinking, well, of course, that's never going to work. Computer's never going to work like that. But you can see Steven talking to it.
Yeah. Well, one of the things I wanted to experiment with, can I do an experiment in front of you guys?
Yeah.
Let's see here. Share, share. Okay, we're back to this screen again because I wanted to try something. John has his documentation style. I have a more advanced documentation style that I put in here, which does this. So that. Okay, fine. This is ChatGPT wanting to assist me because I have ChatGPT wired up as well. That's this guy right here. So it's helping me adjust the code once it sees patterns. It's not going to know enough right here because it doesn't have the full template. All right. Take a look at encoder manager.spin2 and the method get current values. That demonstrates how we do documentation for our code. It does not demonstrate local variables or pass parameters yet. They are also documented in this form. Can you finish this file with those kind of comments? I need to give it the full template for it to do it well. But let's see what it does. And then we can make. So I gave it a pattern. I said, can you do it for the file? And the reason I use this pattern is because the Spin2 extension will use this in hover text when we get it all there. And so let's see what it does. Oh, what? What? It's moving the code. It's noticing how to do parameters. Not bad. It figured it out, I guess. Well, really? My gosh. It's compiling it, make sure it didn't damage anything. And sure enough, there's all our comments. One of the things I hate to do is going back and doing all the comments, and I try to write them as I write the methods. But oh my gosh, so now, if I can get here, will you show me anything now? Yeah, you see it hasn't recognized it yet. So I'm going to do this. I'm going to do this. And which one was that? That was Encoder Manager. Let's pull up Encoder Manager. Listen. Now what does it say? Ah, come on. My codes. I need to have it restudied this code. It's not picking up the comments, but yeah, there you go. So this is what it does, but it hasn't fully realized the comments are there yet because it's giving us this note. But technically now, once these comments are in here, the hover text for a method, whether you're in this object or not, show up in VS Code. So when I use this method from somewhere else, Encoder Manager, I should be able to see those comments. What's in Ink Manager? Do I have Ink Manager call in here? Yes, I do. So tell me what you know about start. And there it is, except for insert comment. It's not recognizing the comment there. I got to figure that out. But the net result is once you have these all commented, as soon as you start having, as soon as you start referring to the methods, you'll get the help text. And as you're typing these parameters, it'll tell you what each parameter is and why you're typing it. So that actually helps you write the code once you document your methods this way. And so what I did was we just took a file. I wanted to see if it could figure it out. We took this file. I showed it how to do a comment. It actually got it reasonably close and was able to document my whole file for me. And that's the way I want to, all of the public projects I'll be publishing in my repo from here on out will have this kind of documentation built in, so you can then understand what this method is doing. The Spin2 extension interprets the documentation and forwards it to wherever you're using it. Documentation for constants can be on the same line with the constants. For an enum, you can put the block of constant above the enum and it'll find it and add it to the enum declaration when you hover over it. And so all of that is working as well. And when you hover over a constant, it should give you the constant value when you're talking about constants coming from other objects. And so I'm basically improving the extension so this hover flyout stuff is useful. Maybe now with Claude, I'll be able to figure out why this stuff isn't coloring itself the way it should be. And we'll get better and better presentation in one of my next releases. So that's what I wanted to show you is Claude can actually help us document the code and unit test the code and write the code. So it's getting pretty darn complete. Now, I mentioned John and how Johnny Mac likes to comment code. He uses a different style. And yes, we can have Claude replicate his style as well. So if he has a favorite style of commenting files, he can comment his files the way he likes to with Claude Assist if he wants to do that. So it's very feasible. If you have your own favorite pattern, you can do it. I tend to do patterns that reinforce the power of the tools. That's why I'm doing this. But there we are. That's all I wanted to show there. Just something new and fun. And I don't have to write as much documentation anymore. Thank you, Claude. I'll take it.
Stephen, I got a question about the YAML files. Are you generating that through automation with an LLM, or do you manually format the YAML files in your manifests?
Formatted with the Opus large language model.
Okay,
So Claud Code doing it, and it is studying the documentation in detail and coming up with how best to document what it's finding. So if you find any errors with anything, let me know and I'll go back and repair. If you find information is incomplete, let me know. As I find new information sources, I'm making sure to go back and augment and decorate.
right, and you prefer vetted documentation from Parallax and you're not taking anything from the forum, it's vetted, it's
Correct. My point of starting vetted is we need this to be the truth for the P2. I'm not going to have any problem with the forum and the members contributing idioms or contributing favorite patterns for doing things. We want to incorporate that. But I need foundational truth for the P2 because that's how we get to working code. Is my thinking. You know, I'm willing to entertain other thoughts, but you know, we have to have, this has to be the source of truth for us that's as rich and strong as Parallax wants to have for all vendors to use, right?
But as a user, if I wanted to add something to the knowledge base, would it be best to be in the format the LLM consume as it, like, for instance, the YAML file? Or
Oh, Kevin, it could be anything you throw at it.
right.
That's the key. What I did, and the reason I came up with YAML files, is I work with the LLM Opus to actually say, if you had your druthers and you had the most efficient and the best storage format for download on demand, what would you use? And it thought about JSON, it thought about YAML, it thought about markdown files, it thought about all sorts of things, and finally said, YAML is actually weaker in structure than JSON, but at the same time, it's a faster, quicker load and easier to transport. And so it made the decision that way.
Right. So when Chip was doing his demo, he used a file that was referred to in the knowledge base earlier on. You know,
I just gave it the URL of our sheet that has all the instructions, and it used that.
He gave it the Google Docs, right? He gave it the Google Doc location. He didn't point to my database for it.
Stevens is more dense.
Right.
Oh, so you didn't put that in the Claude MD file?
No.
Oh, I see. Okay. I get it.
No. If that were in the, what happens is Claude MD, for every command you type in, Claude MD rides along with every query you have. And so one of the requirements you have to have is Claude MD has to stay token tiny. And so it's not uncommon for me to be working a project and be needing to remember things and remember things. And finally I say, okay, this has gotten too much. I need you to study your Claude MD, and I need you to keep everything essential and study it for brevity. Don't lose any content, but reduce the token count. And so every now and then it'll take a 2K file and drop it back down to, half a K.
Right.
Because it rides with every command. And so you have to keep it lean and mean. However, some of the things we learned, my son has been doing this with very large file sets. And one of the things he learned early on is that if your project is large enough, it's wise to have Claude study the project and record the tree shape in Claude MD. And the result of that will be that when it's looking for one of the files in this collection, large collection of files, it knows where they were, where they are now, and it stops the searching through the file system for the file it's looking for. And so it got dramatically more efficient.
Mhm. So yeah, that's another point I wanted to bring up. Last meeting, I used Claude Desktop and I inserted the Claude MD file, and it choked on one of the manifests, and I had to put in the URL for the manifest on your GitHub. Now,
Yeah.
is there a limitation with desktop Claude versus CLI Claude?
No, you're probably going to need me to apologize. What I found today was that a number of the manifest paths were broken. And so it was getting 404 errors for some of the
Right.
content, right?
Okay.
So
Yeah.
then it will try it'll try methods you wouldn't believe to search the entire GitHub repository to go find things. That's not what I want. And that dramatically wastes your conversational context, because it's searching through the entire repository. There's a huge amount of stuff out there that has nothing to do with the knowledge base. And so I found those today, fixed them, and got them repaired before the demos. So the OBEX linkages were broken, for instance. Some of the patterns were broken. Smart pins, 22 of the 32 were missing. It's like, what the heck? I have already done 3 audits through that database. This was the 4th, and I still found things broken.
Wow.
Now what I have is a formal audit script for every time I find changes in the YAMLs. I run the formal audit before I publish it and release it. So broken links will not happen anymore. But you probably hit it while I had broken links out there. That would be my.
So I could use the desktop?
You should be able to.
Okay. Okay.
The CLI and the desktop should be the same thing. Now that's something else I wanted to show you. I'm going to share my screen again because it can be a little bit more entertaining than we think. So I'm going to go this. And now you see there is a Claude Code extension for VS Code. Okay. If you have the Claude Code extension, it gives you a different way of working with Claude Code than the desktop or the CLI. And what we end up with then, and I'm going to forget how to, oh, there you go. Click on this little guy. Can you see him?
Mm-hmm.
You click on that, and now you get a vertical half window, which is Claude working in your project. Now you can see your code, you can see your files, and Claude right here, and I'm not running a separate term window anymore. Look at me typing. That's not what I want to do ever, but I actually typed. Some days I'll forget that I have a push to talk button on my keyboard now. So it just started up in this directory with a new context. It does have the Claude MD. And I said, what can you tell me about the files you're seeing? And I just asked it to go out and study it, and let's see what it learns. So my point here now is this is an integrated way to work with Claude Code in VS Code. You no longer have to have a separate terminal, and you can do everything here. The difference is, if I'm working in a container with a protected file system, I'm going to run Claude in a different mode so it doesn't ask me permissions to do things than if I'm working on my desktop. If I'm working on my desktop, then I use this kind of environment because I can't give it the extra permissions to don't prompt me. And so my file system is protected. And so here's what we learned about the project in the file. And so I just asked it, I said, study where you are, tell me what we're doing. And it has it. And so pretty cool. So this is the other thing I wanted to show you. This is another very useful way to do it. And Claude, when you have a file open now in the bottom right, it's going to show you which ones you have open and what you're doing. Things like this. If it ever gets disconnected, you'll see disconnected. One of the extensions I use, OBJs are not very useful, so I keep a hidden items extension here. And I say, I want you to ignore all of the OBJs in my file list. And so it makes them go away. I want you to ignore all my bin files so I don't have to see them and try and pick and choose the file I want to see in my list. And so now I may keep the list files because those are fun, right? And then also, I just documented that one file. Where is it? What are you doing on that side of Claude? You're messing with me. All right, is this the file I documented? Yes. And so now I'm going to do this. And now I have the external documentation for this file with just the command sequence. And now I can publish the interface to my objects, right? And so that's just when you start up my Spin2 extension and you ask for key mappings, key bindings, it'll tell you how to do the insert the comments and how to generate this document file.
Nice.
And so this, just like we used to get out of Propeller tool, is the same document that we can generate. And so this is another reason why I added all those comments, is it's pulling all those comment information out. You get a well-documented object. Things we expect to see in the future. All the contents of it, all the constants for the objects with their documentation, all of the structures I'd love to see in this report, right? And so imagine that that's going to show up eventually too, because they further describe the object. We won't have an ability to select which constants are public, because technically all of them are public. So it'll be a long list of constants once we include that, but at least they'll be here for documentation regions. Okay, that's all I wanted to show you again this time, and that's the use of Claud Code in your extension to set it up and use it. It makes it quite easy when you're in VS Code to say self-contained in one large window and have Claude right there. We can switch to other windows, and we do get kind of used to this. Sometimes I'll run my Amber on black, but having it in line for Spin projects is just really nice. Just another observation.
Can you tell Claude to put a new battery in your wall clock behind you?
Do I want to be around when the robotics are sitting here that Claude's driving and it's trying to get to that wall clock and it knocks me in the head while it's trying to? The answer is yes, I could if I had enough external controls, because Claude can run anything I give it. So we have to be careful what we give it. Make sure you give it good sensors at the same time so you can avoid us humans and pets and things. Yeah, it's stunning what we can have controlled now and what we can make. We have to be responsible to each other, do nice things to each other when we're delivering these systems, right? But it's fun. It's fun. I love identifying new hardware that I haven't played with before, grabbing it, studying the data sheets, and then making code run it with a P2, because people try these things with different hardware, with Arduinos and with other ARM systems and pies and things like this. And we can just far outrun the sensor ability and the control ability with our P2s. And I love to try it, make objects. My time to creating a working object now, as Chip was saying, by studying the data sheets and studying what's going on, is so much shorter because I'm using Claude to do this, right? My quality of product, because I'm using Claude to do it. When I first release new objects now, I don't have to spend another 3 hours writing all the documentation anymore for my new public object. You know, this is huge. Studying the data sheets is fast, documenting is fast, creating more testing scaffold than I would have created is fast. So there's no excuse for my releasing objects that work under some conditions anymore. You know, if it's a self-contained object and you can provide fed data to the object so you can fully range test it, you have no excuse for releasing bad objects anymore. It's very cool. I'm pleased. So, yep, one more observation, huh?
All right. Well, let's see. We're at the 2-hour mark.
I think
And,
it's time to quit for today so we can do other things. But this has been,
Yeah.
I hope you've enjoyed it. This has been fun.
Yeah, this is
Yeah.
great.
Thank you.
Thank you so much.
Glad to. I look forward to having full hardware round trip for the next one. Having this actually work on this one was stunning because this is the first time I actually tried it live with you guys, and I'm pleased it's working pretty well. So
Yeah, I'm looking forward to the debug too. That's going to be cool.
it's essential.
Yeah.
It's essential. One of the things I have in the I'm just going to advertise in advance. I never like to do this, but because I have the document in my hands, I'm in finishing stages of making the document pretty. The full content is there for a full rich study of all the debug window parameter sets and giving us new examples for how to do debug windows with a no hardware situation. It's a very large document, but you figure it as just kind of a menu. You go in and you look at the large document and say, you know, I could use something like this, and it gives you the recipes for how to do it. So that's coming. That's going to be one of the documents we release under this new effort.
Steven's debug cookbook.
There you go. Yep. The debug cookbook. Yeah, so it's going to be fun. Some of these are going to be up for the community to help, you know, troubleshoot and certify. But I think we're going to have fun doing it. You know, it's all the code before I release the book, all the code compiles clean, and it will have run clean because I'll be doing screen captures. And so by the time you see the publication, it's tested code, which is going to be very cool. That's my last advance notice. my peak, my teasing of what's upcoming for today. All right. Anything else, anybody?
Guess we're done. Thanks everybody for coming today.
Thank you, everybody. I look forward to our next.
See you next
Okay.
time.
Okay.
Yep.
All right.
See you next time. Thanks everyone. Well, I will see you a little later, Stephen.
Okay. I look forward to it. Bye for now.
All right. Okay. Bye-bye.